Yes, am I audible, Fadil?
Yes, ma'am.
See, Fadil, I think Shahid hasn't joined till now. So what we do, I was just asking, see, EMI is currently going in this lesson, but in your batch, EMI has not been completed. So what do you prefer? For me to continue with EMI today, or do you want me to go and do bio law first with you? Because that has been done recently in your batch.
Ma'am, we can do bio law.
Bio law, okay. See, firstly, Fadil, before we go into the details of it, Biot-Savart law was what? Biot-Savart law basically said that the magnitude of magnetic field, this is directly proportional to three things. First is the current element. Second was the current which is flowing through the wire. And third is the angle. That is angle formed between the current element and the position vector. All right, so magnetic field is directly proportional to these three things. All right. Then there is a point at which you want to calculate the magnetic field. So at this particular point, the separation with the wire, we take it as position vector. So magnetic field is inversely proportional to position vector. All right, magnetic field, this is inversely proportional to the position vector. So the constant term that comes here becomes mu naught by 4 pi, whose value is 10 to the 4 pi into 10 to the power minus 7 ideal sine theta divided by r squared. In vector form, we write it in this manner. And if any, have you written this, Fadil? I think you, when you had joined, we were doing this or not?
Yes, ma'am. Yes, ma'am. We were.
Have it, no written. Okay, then I'll scroll
Yeah.
it. Now, see, if any point is lying on the axis of it, if any point is lying on the axis, then we say Biot-Savart law is directly zero. Because why? Magnetic field becomes zero. Magnetic, that angle is 0 or 180 degree. So you should remember magnetic field on the axis of current carrying conductor is always 0. And magnetic field on the perimeter of circular loop is always minimum. Why? Because at the center it is mu naught I by 2. At this derivation we haven't done. So that we'll discuss in your batch, then it would become better. Now let us practice with questions then directly. Now, Father, tell me, just calculate, use Biot-Savart's law. One line, you will get your answer. Just first try it.
Yes. What is the answer?
What's your answer coming, Father? See,
Ma'am,
see,
yes.
this is 90-degree, right? This entire. If you look at it as a whole, let me mark this as A, this as B. So can you see in triangle ABP, angle B is actually 90-degree. So if this is 90 degrees, so this is alpha. Just take this triangle first. So if just forget that this is one line over here. Let's say this is C. Forget that CP is here. If CP is not here, how much can I write this angle as? This tell me, Father.
Ma'am, 90 minus CA, alpha 1.
Alpha 1. Perfect. This becomes 90 minus alpha 1, this entire angle. And when I'm talking about just this angle, this tiny angle, so this is alpha 2, this is 90, so it will become 90 minus alpha 2, right? Now see,
Right.
when we are applying Biot-Savart's law, so what is your one angle? One angle is, see, we calculated from the periphery. So for the first angle, the angle subtended at point P we'll take. This becomes 90 minus alpha 1 and second becomes 90 minus alpha 2. Now see, in one line you will get your answer. B is equal to mu naught I 4 pi, separation is D. Sine, we take the first angle and second angle, right? So the angle from point A that is being subtended, because we always take the perpendicular distance. So this becomes 90 minus alpha 1, right? Minus sine 90 minus alpha 2. What is sine 90 minus theta?
Cos theta.
Cos theta. Perfect. So the answer is mu naught I by 4 pi d cos alpha 1 minus cos alpha 2. That's it. Clear?
Yes, ma'am.
Okay. Write it down. I'll share some more questions.
Okay.
See, main formula, no, whenever you have any wire, go by this formula, mu naught by 4 pi r, whatever is the separation, sine theta 1 plus sine theta 2. All right. Now see here what happens. This angle is 90 degree. You have to join it. See, when you will join it over here at one end to find this angle that is being made at point P, what are you seeing? This is at infinity. So see, this line basically represents that this is extending up to infinity. So angle ultimately becomes 90 degree. This angle could have been like this, no? If suppose this is a wire, the angle that is subtended, we calculate it like this. If the angle is increasing, we'll calculate it like this, right? The angle is increasing more, we'll calculate it like this. And so it is increasing. If it has increased up to infinity, so from infinity, you have joined, and ultimately it will appear like a straight line, almost equal to 90 degree. That's why this 90 degree has been made in the figure. This is not a wire that has been kept separately. Here, look, if it's a very small angle, you will see a greater subtension. When see the
Yes, sir.
inclination of this. Now look, I've just increased the wire like this. Can you see how much inclination has been increased? This much. Earlier,
Yes, sir.
it was just this. So if it is extended up to infinity, it means this will be such a huge straight line. This is what is meant by this straight line. First, just tell me, this is clear why angle is 90 degree.
Yes, sir.
Okay. Now see, once the angle is 90 degree, other angle is given to you as theta. So just substitute it. This becomes mu naught by 4 pi. Separation is given as d. First angle, take any. This is sine theta and sine 90 will be 1. So that's it. This is your answer. This much of Tesla will be the answer. This is how you have to find out if wire is given and 1 point is given. You will just take the angle that is formed by them with this perpendicular separation theta 1 and theta 2. Some
Okay.
combined question, let us see, based on these infinitely long wires.
Ma'am, sine theta 1, we write it as sine theta itself.
See, why have we written it? Because in the question it is given as theta. So we cannot put values on our own.
Right, sir.
Had it been given something, we would have calculated.
Okay. Ma'am?
Yes, Fadil, any answers?
No, ma'am, but I think it is C.
It is which one?
C, maybe.
C. No, it's A
Because
actually.
we won't have.
A cap minus I cap.
Oh, okay.
See, let me tell you. This is actually a very good question because all the options are almost similar with just plus minus signs different. Which is the point that is given to us? Point is 0, point is 0, 0, minus.
Minus A.
Yeah.
Yeah.
This
So it lies on Z axis, right?
is lying. No, what do you say? No,
It
see,
lies on Z.
equal current is flowing in three infinitely long wires along positive. So X, Y, Z directions. The magnitude of magnetic field at a point 0, 0, minus A. This we have to find out. X, Y, Z. This you're saying?
Yes, ma'am.
Yes. See, current along Z axis or any axis. Forget about the axis right now. Just forget about the axis.
Okay.
Firstly, whenever you have such type of questions, first thing that comes is magnetic field due to current, whichever current is the current I in X direction or Y direction, which we are calculating. First point is that how much value of current would it hold if the point is suppose lying on one axis. These are different axes. If a point is lying, it means the separation A is given, right? If it means the separation A.
Right.
See, if point is, suppose this is the negative Z axis, this is the point which we have to calculate. So point is currently lying on this. When we are calculating due to Y axis or we are calculating due to X axis, these are the two possible, right? Two possible axes which we can calculate. Now, obviously, the D option is never possible. Mu naught I, this one, I cap, J cap plus K cap, because K cap
Yeah.
involved cannot be there, right?
Right, right.
Yeah. So we are left with three options. Either J cap minus I cap plus J cap, or I cap minus J cap. That we have to do. See,
Yeah.
when the point lies on x-axis, magnetic field due to the current along one point will be 0. Magnetic field along z-axis is 0. See, magnetic field along z-axis is 0 directly.
Yes. Yeah.
And due to the rest of the wires, because since we know the separation is A, and always this perpendicular point is taken. So how to firstly, I'm focusing on the magnitude. So due to x, it would be mu naught I by 4 pi A. Then again, due to y, it would also be mu naught I by 4 pi A. When you will add them, this 4 pi 4 will be cancelled, and ultimately you will have it as mu naught I by 2 pi. So I think this is not the issue how mu naught I by 2 pi. And obviously it's same in all the answers. So in any ways, we have to have mu naught I by 2 pi.
Yeah.
See,
Right.
magnetic field due to the current in x direction is along the y. When you are calculating, suppose this is the point at x at which we are calculating. When you are calculating at this point, magnetic field due to the current along x and y direction you have to determine. This is x, this is y, this is z. Only one information that you have with you is that x-axis, z-axis is negative. This means. So when z-axis is negative, magnetic field due to current in x direction, when you are calculating, that is along y. And magnetic field due to current in the y direction will now be along the negative x-axis. See, why not this? Why only this? Y-axis is clear. Y-axis will definitely be here. Now see, if you will substitute, if you see here, this is negative, right? It means this is minus z. These are all the possible axes. Let me redraw it. See, this is clear. I hope the magnitude, which is mu naught I by 2 pi a. Now let me draw the figure properly so it would be clear to you. See, these are all the axes that are given to you. So one will be x-axis, this is your y-axis, this is your x-axis, and this one is the z-axis. Now I'm drawing it properly. See, current I is flowing along this axis. Fine. Current I is flowing along this axis, current I is flowing along this axis. So three infinite wires are present. Now magnetic field, just a second, Father. Okay, now see, three currents are flowing in all the different directions. So at a random point, let's say this is a random point which I have taken because this is negative z axis, so I'll prefer this one. So at this point, when I'll separate it, when I'll resolve the vector, one will be, sorry, this will be along y-axis and this is along x-axis. This is simple resolution of vector because I have to have this magnitude as mu naught I by 2 pi a. So it means this is the resultant. So this is because of bx and by. All right. So when we are calculating along bx, see, how will you calculate along bx? Mu naught I by 4 pi a was already there. Now you have two angles with you. Sine 90 degree plus sine 90 degree. Why? Because these angles are perpendicular. When you're calculating it for x-axis, all the three axes are making angle of 90 degree, right? So angle for x-axis, both the angles for x-axis will also be 0, 0, and for y will also be 0 and 0. Now see, when you are calculating it for x-axis, this is going along the negative side. See, this is the negative axis, this is the positive axis. So this will become, this is minus I cap, right? This is negative x-axis. Now when we are calculating for the y-axis, see, this is mu naught I by 4 pi a. That becomes sine 90 degree plus sine 90 degree along j cap. See, this I told you already that 1 plus 1, 2 will become 2 here. And by will also
Yes, sir.
become
Yes, sir.
sine 90 plus sine 90 is 2.
Mm.
So net, which was mu naught I by 4 pi a. This is j cap. This is minus I. So which option is matching with this? J cap minus I cap.
A.
A option. This is how we've got A option.
Okay. Done, ma'am.
All right, Fadil. I think time is already there. You can leave now. Next week we'll continue this. All right.
Yes, ma'am.